So, we are discussing about sulphate, and I was telling you that 200 up to 200 ppm is usually allowed according to WHO standard, and but the normal standard for drinking water is about 150 milligram per liter, that is 150 ppm. So, normally as a precaution, water with sulphate level exceeding 400 ppm should not be used in the preparation of infant formula, because I was telling you that infants are more prone to go through to sulphate abuse, and we have to make sure that the water used for infant feeding etc. should not contain so much of sulphate. So, beyond this, gastrointestinal irritation also occurs when magnesium and sodium are present, which are the common constituents of water. So, animals are also sensitive to high levels of sulphate. In young animals, sometimes high sulphate levels are associated with severe chronic diarrhea, and in few circumstances death also, higher concentrations, but only with younger animals. So, just like humans, animals tend to become accustomed to sulphate over time. So, higher sulphate does not really result in problems, but if the sulphate level exceeds 250 milligram per liter, the bitter taste will continue, and astringent effect, astringent effect means somewhat undesirable effect, taste. It may render the water very unpleasant to drink. So, high sulphate levels also cause plumbing, particularly copper in copper piping. They can cause scale buildup that can produce a black slime resulting in clogs, and it produces stains on the clothes etc. So, most of the plumbing materials are resistant to corrosion such as plastic pipe. So, to avoid that, people use plastic pipe, but it does not do away with the problem of sulphate. So, sulphate ion is normally precipitated in acetic acid medium with barium chloride. This is a very standard procedure for the preparation of for the determination of barium sulphate. It is a very high school level chemistry. Barium sulphate is highly insoluble in water, and acetic acid medium helps in producing barium chloride good crystals, so of uniform size. So, normally light absorbance of barium sulphate suspension is measured by a spectrophotometer, and the sulphate concentration is determined by comparison of the reading with a standard curve. See, the problem with the determination of sulphate is the normal method for precipitation of sulphate is by gravimetry, and there are number of other methods also for the determination of sulphate, but in ppm level you have to work harder to, because the precipitate may not be in a weighable form, you may not get enough of the sample to precipitate. So, that method has been modified using spectrophotometry. It is not done by us, method is already there. What we have done is we have tried to downsize the whole operation to smaller volume, so that the experiment can be carried out at faster with less use of chemicals. So, these are the reagents what we need. You just need sodium chloride and hydrochloric acid reagent. You have to dissolve 24 gram of sodium chloride in 80 ml of distilled water, and add 2 ml of concentrated hydrochloric acid to 100 ml in a volumetric flask. Then you also need a glycerol alcohol solution. This solution is required to keep the precipitate in suspension form, because I have already explained in turbidimetric methods during our discussion on the instrumentation. During our discussion on the instrumentation, I had mentioned to you that any gravimetric method can be converted into a spectrophotometric method, provided the precipitate is kept in solution. So, the same principle here, there I had mentioned that any precipitate can be kept in suspension using viscous liquids. Sometimes polyvinyl alcohol you can use, or you can use glycerine, or you can use glycerol alcohol solution like this, only to increase the viscosity and to ensure that the precipitate does not settle down during during the measurement. So, that is the only purpose why we use glycerol alcohol solution in the determination of sulphate. So, the procedure is very simple. All you have to do is pipette out standard sulphate solution in 10 different flasks, volumetric flasks, add 1 ml of sodium chloride and hydrochloric acid reagent. So, add up to 200 microliter of the glycerol alcohol solution, followed by 1 ml of barium chloride solution. So, the barium chloride will react with the sulphate present in the sample to give you barium sulphate, and the alcohol glycerol solution will help you to keep the solution intact, that is no precipitation should occur. So, you have to, what you should do is close the lids and mix it by inverting 20 times. So, the conversion of this 20 times mixing is only arbitrary. You can mix it for 40 times, 50 times, it is any number of times, but the requirement is you should be able to mix it in a reproducible manner. If you have a solution like this, all you should do is do it like this in a very reproducible manner, so that precipitate will not grow in size also, because that will result in more of scattering radiation, not the absorbance radiation. So, if you are able to do this exactly for each of the sample as well as blank, you should be able to measure the absorbance, because this precipitate will remain in solution, it will be of uniform size, the scattering will be less, and all these properties you can observe. So, this is the only method among the water treatment chemicals, water parameters I am recommending as a spectrophotometric method, even though many of them can be followed by using this, but it depends upon your ingenuity to adopt. I am only giving you an example here, but any precipitation method can be used for the spectrophotometric application. So, then supposing you do that, then you measure the absorbance of each solution at 420 nanometers. It is a white colored solution basically. So, it does not matter which wavelength you use, but 420 seems to be fairly good wavelength. There is no hard and fast rule that you should use only 420 nanometers. You can use any of the wavelengths available on the spectrophotometer as far as white precipitates are concerned. So, the recommended sample volume is approximately 1 ml, because the concentration may vary from 250, 50, 100 like that. And then cookbook value, for we have prepared cookbook value for 250 milligram of sulphate in 10 microliter 10 ml, that is about 25 microgram ppm. That should give you an absorbance of about 0.206 plus or minus 0.04. That means the allowance here plus or minus 0.04 indicates that for turbidimetric methods you should keep a larger allowance for accuracy. So, this is a method. Again I want to draw your attention to the calibration curve. The calibration curve is not at all linear, but it does not, it is necessary that it should be linear. This is one classic case where the calibration can be non-linear, and but if it is reproducible, we should be able to use it for our purpose. Now, the R square value obviously will not be very good if you want to fit it into a linear quadratic equation, but 0.987 is value what we have got, and if you are able to reproduce any of the results with a reasonable accuracy, you should be able to go ahead and complete the chemical analysis with a spectrophotometric finish. If otherwise, there are many other methods one can go depending upon the accuracy required. So, I want to stop our discussion on sulphate at this level, and then we will move on to ammonia. This will be the last of the parameters which I will be discussing with you for water quality monitoring. So, we will not take much time regarding the determination of ammonia, but as prior information I have to tell you that ammonia is again everywhere, and it is there in the air what we breathe to some extent, and chloramines are being used in water treatment, and then chloramine T and etc. they all they are used. Ammonia is an industrial chemical. It also is used as a medicine in many of the wicks and other substances which you smell when you have a cold, and industrially ammonia is produced in several millions of tons every year, and ammonia is being transported across the country for several purposes, but if there is a leakage of ammonia, it leads to sort of toxic effects on the people who are exposed to that. And what I would like to tell you is this reaction with indophenol, ammonia reacts with hypochlorite to form chloramines, which react with phenol to form indophenol blue. So, this is the structure of indophenol, that is with a ketone group and nitrogen, and then there is OH group. This is technically 4,4-hydroxy phenylamino cyclohexa 2,5-diene 1-one. Okay. So, the reagents required for this are sodium hydroxide, because the reaction proceeds in alkaline medium. It is good also. You have to dissolve 40 gram of sodium hydroxide and dilute to 100 ml. You need phenol. Phenol is available across the shelf, and 11.1 ml liquefied phenol and 5 gram of sodium hydroxide can be diluted to 100 ml. And then you need sodium nitroprusside, 0.25 gram of nitroprusside in 50 ml of water. And then you also need alkaline citrate, citric acid buffer, approximately about in alkaline medium. So, that is, you have to add sodium hydroxide in water and dilute to 100 ml. So, you also need sodium hypochlorite, just a chemical available across the shelf. You have to dissolve 25 ml of commercial sodium hypochlorite with 1 ml of 40% NA, dilute it to 100 ml. Then stock ammonium solution you can prepare by ammonium chloride. You have to weigh out 0.3819 gram, dissolve it in water and dilute to 100 ml. Standard ammonium solution that is working solution. You have to prepare 10 ppm, that should be more than enough. The reaction is you have to prepare 250 microliter of 1000 ppm solution and to 25 ml. And the procedure involves pipetting out up to 10 ppm solution in 10 ml volumetric flask, add phenol, sodium nitroprusside, alkaline citrate and sodium hypochlorite. All you have to do is mix well and let stand for about 30 minutes. Indophenol will develop, and only thing I want to tell you at this point is you should do it in diffuse light. Don't do it in sunlight conditions. So you can read the absorbance at 640, that produces a very bright blue color solution, and recommended volume is 1 ml for your sample, and cookbook value for 5 microgram of ammoniacal nitrogen in 10 ml gives you an absorbance of about 0.50, that is 5 microgram in 10 ml is about 0.5 ppm. 0.5 ppm in giving you an absorbance of 0.50 is a very good sensitivity. So, this is the absorption spectrum of the complex versus a blank, standard blank without ammonia, and you can see that the method has got a fairly good sensitivity around 620, 640. You should be able to get a correct absorbance. And this is the calibration of ammonium ion in water. You can see that it goes through this origin, and up to 1 ppm you can get a fairly good linearity. The least square feet gives you an R square value of about 0.9987, which is fairly good, I should say. And I would like to tell you that this completes our course on the molecular absorption methods using spectrophotometry and related techniques for pollution, water pollution monitoring. What I have tried to teach you in this course is a very important aspect, that very simple chemistry can be used to advantage to monitor the environment around us at the levels prescribed by the central government or any other government agency for the environment. So, this whole course, what I have divided into basically 3 parts. First one is the theoretical part, which I have gone in detail, telling you about the structure of the atom and how molecules and molecular orbital theory etc. can be used to advantage regarding the spectrophotometric, that has laid the basis of spectrophotometry. Then I have gone into the theoretical aspects of spectrophotometric technique, that is transition from bonding and non-bonding orbitals, and regarding the whether we should be able to convert a given structure and predict where the lambda max can be obtained. I have also discussed with you the instrumentation in great detail regarding the spectrophotometry and the associated techniques, that is modular techniques which can be added to spectrophotometer, including gravimetry, including the turbidimetry, nephelometry, luminescence spectrometry, etc. And I have also discussed with you a little bit about reflectance spectroscopy, that is for paints, etc. And then in part 2, what I have done is I have selected about 21 parameters for water quality monitoring and explained to you how these parameters can be monitored using spectrophotometry. Basically, the whole thing is an exposition of spectrophotometric technique to you, so that once you are able to go through this course, you will feel very familiar with any spectrophotometric technique. You will also be able to design new experiments based on the course content what I have given here. So, I hope you have enjoyed the course, and the one more outcome of this course is I have given you a cookbook containing how to prepare the solutions, even though the last part is maybe slightly boring to you because it is a sort of repetitive. Last 5 classes I have taken you through 21 parameters and how to prepare the solution, etc. That should serve you as a cookbook itself. So, if you want to work, you do not have to look for sources of information anywhere else unless you need. So, this is what I have tried to teach you. I hope you have enjoyed the course, and I have also enjoyed the teaching you this course, and it has been a rewarding experience for me, and wish you all the best. Sarve Jana Sukhino Bhavantu. All the best. Thank you very much.